We know that the amount of debris in the ocean and also in the coastal area are increasing.
Niejednokrotnie zdarzają się po prostu zupełnie puste połowy. Wracamy z niczym.
Those pollutants entering the marine environment directly affecting microorganisms, and the microorganisms are on the base of the food chain. And finally, this leads to a reduction of the fish stocks in the seas and in the ocean.
U nas w Sopocie jest 5 łodzi, kiedyś było 16. Sytuacja wygląda dosyć dramatycznie. Teraz powinien być sezon na dorsza, a tej ryby po prostu nie ma. Najwięcej ojciec miał ponad tonę flądry. Od 2010 roku, powiedzmy, widzimy tą tendencję spadkową. Paszowce robią to spustoszenie, zanieczyszczenie, zmianę klimatu. Myślę, że to jest złożony problem.
Where are we now and why you are conducting your research in such a places?
So we are here close to an estuary where a river enters the sea. And this is a perfect location where we can investigate the effect of pollutant coming from the land and entering the sea. And here we have the highest concentration of the pollutant. Basically, you can separate them in organic and inorganic pollutant. If we're talking about inorganic, then we have all those heavy metals coming from the shipping industry, coming from the factory, from the mining, but also from the electronic waste. And on the other hand, we have the organic pollutant, which are most interesting for me. They're coming from the aquaculture, where they, for example, antibiotics were directly added to the water body, but also indirect from land, where farmers added some pesticides to those crops, to their land. And all those pesticides then enter the groundwater and will wash out from the land via the rivers to the coastal areas like here. I'm interested in microorganism which lives in the uppermost centimeter of the seabed. So what I do, I scratch the sediment, the first 2 centimeters of the sediment, and then I sieve them directly on the shore, so with fresh seawater. So and after that, I collect those received sediments containing all those microorganisms I'm interested in and send them back to the laboratory, where we started the main culture, and from this culture we do our experiments in the next couple of weeks or months.
Turyści chyba nieczęsto mogą kupić rybę stąd.
Kiedy my pływamy, to oczywiście jest możliwość kupienia surowej ryby, jeszcze żywej, prosto z burty, powiedzmy. To jest około 6 miesięcy w roku. W sklepie mamy tylko wędzoną rybę, ją mamy cały rok i ją po prostu sprowadzamy z wędzarni, z Władysławowa, z Pucka.
Skąd są te ryby?
Morze Północne, Atlantyk w większości.
So how pollutants affect microorganisms in the sea here and cause problems for example, fishermen here?
Water coming from the mainland, they contain a high amount of particles, microparticles like microplastic or nanoparticles, and they will be enriched on those microorganisms. And fish, for example, eat those enriched microorganisms, getting self-enriched with those particles. So nowadays, if you collect fishes from, for example, the Baltic Sea here, those fishes are enriched with metals or with nanoparticles or microplastics. The biggest problem is with those fishes when you have a lot of fat, because those metals, like for example mercury or lead, they will bound in the fat. And if you eat then a lot of those fatty fishes, then you have a high amount of those metals you incorporate in your body. Mm-hmm. So here are our main cultures from our foraminifera. So we have different cultures from the North Sea, from the Baltic Sea, and from the Mediterranean Sea. And you can see here inside those cultures we have our microorganisms we are interested in. They are called foraminifera. Those are marine protists, which you can find in all marine habitats in the coastal area, but also in the deep sea. And due to their high abundance, they are very important for the carbon and nitrogen cycle. Since they are microorganisms, they are on the base of the food chain and important for higher organisms to feed on. So when we do our experiments, we have different setups. We have a control sample, So foraminifera were incubated without any interference factor, and then we have different setups with interference factor, meaning we add a certain amount of antibiotics or pesticides to the cultures, and after a certain amount of incubation, let's say 3 or 5 days, we check the difference between the interfered forams and the control ones. So we check differences in their metabolism, in their growth, in their reproduction, or also on their cellular level.
Na co masz nadzieję, na co liczysz?
Że po prostu się zmieni, że po prostu ta ryba przyjdzie. Jednostek jest coraz mniej, rybacy odchodzą na emeryturę, łodzie są złomowane. Mam nadzieję, że przynajmniej tutaj w Sopocie te łodzie zostaną, bo to jest nieodzowna historia tego miasta. Nie wyobrażam sobie innego zawodu, innej funkcji w moim życiu. Perspektywy są ciężkie, ja mam nadzieję, że coś się zmieni. Co? Nie wiem, to do naukowców, do biologów.
So this research in general is necessary to broaden our knowledge about the interference of pesticides or antibiotics, let's say in general, pollutant with organism. So we incubated our foraminifera with different pesticides. So we used one herbicide, one fungicide and one insecticide. And it turned out that the herbicide and the fungicide, for example, are highly toxic for the foraminifera, and the insecticide are less toxic for them. So finally, we want to make conclusion which substances should be avoided in future by agriculture or, for example, in agriculture. We should always think about that we are, as a human, we are part of the food chain. Everything we put in the environment, all those pollutions will be enriched in the environment and then in the organism, in the microorganism, in the higher animals, and we finally eat those animals and getting self-enriched with those pollutants. My name is Michael Lintner and I'm from Austria. I was born and raised in Vienna, and now I'm doing my research here at the ING Pan under Polonez Bis fellow.